this is a solubility graph, okay? Now, these are 3 different solubility curves for 3 different solutes. All right, so I have sodium chloride, potassium chloride, and potassium nitrate here. Do we all see this? Okay. On my y-axis, I have grams of solute dissolved in 100 grams of water. So this is going up, how many grams of this solute I have, okay? My x-axis is temperature. Does temperature have an effect on the solubility of these substances?
Yeah.
Yes. How do I know that?
Because it changes, it goes up as
Right.
the temperature goes
So
up.
especially with potassium nitrate here, I'm looking at this, as the temperature increases, can I pack more in there?
Yeah.
Yeah, right? So if I had a beaker of stuff, okay, let's say that I had, it's 100 grams of water in here, I keep raising the temperature with a Bunsen burner, pretend that's a flame, okay? I keep raising the temperature, I'm going to be able to pack more solute in there. Why? What's happening to the molecules? They're spreading out. What else are they doing? What happens when I heat something up?
Evaporate.
Vapor.
Nope.
It expands.
So not only are they expanding, but what else are they doing? Moving how? Faster, right? So there's more collisions that are going on. Does that make sense? So think about a bouncy house full of 4-year-olds. And now think about a bouncy house full of 4-year-olds on a sugar high. Right? So if I increase the heat here, it's like giving all of those kids a liter of soda. They're going to be hitting each other all over the place, causing a bunch of collisions. So the heat here is making those molecules vibrate even faster and shoot out in different directions, which is going to hit these solutes and dissolve them even more. Does that make sense? So the more heat, the faster the molecules move, the more solute I'm going to be able to get into solution. That's not always the case, but it's a trend, okay? So, on my solubility curve here, this line is telling me how much I can get in there, okay? Anything below that line, there are 2 words, supersaturated or unsaturated. If I am below this line, which one am I? Unsaturated, meaning I don't have as much solute in there as it could possibly hold, okay? If I'm supersaturated, I'm above this line. So if I'm supersaturated in a solution, what do I expect to see at the bottom?
Particles.
Why?
Because
they all fit in there?
They can't dissolve.
They all can't dissolve because there's not enough room to fit it all. Does that make sense? So my solubility curve tells me at 40 degrees Celsius, I can only get 60 grams of potassium nitrate into that solution. If I have more than that, I'm going to see some at the bottom because I can't fit it in the solution. There's no room for it. Does that kind of make sense? So who's made super, super sweet iced tea? With the powder. And my mom makes it super weak, and I hate it. Right? So she's unsaturated for her iced tea. I'm super saturated because I can see the powder in the bottom. Does that make sense? We're all following me here with this? Okay. So on number 1, on your worksheet, it says, what is the solubility of potassium nitrate in 100 grams of water at 80 degrees Celsius? So I find 80, and where do I go? Up to my line, 160 grams. That's your answer. Okay? Now it is, thank you.